Certifying agencies play a vital role in obtaining global approvals and listings for products, ensuring compliance with various international standards. Several agencies specialize in coordinating these approvals to minimize costs and effort. Firstly, Intertek, also known as TÄV SÄµO, provides comprehensive global certification services encompassing all International Electrotechnical Commission and International Organization for Standardization certifications. Intertek possesses significant experience in coordinating approvals and listings across multiple jurisdictions. Secondly, TÄV SÄöD is a prominent German certification body offering testing and certification services for electrical, mechanical, and industrial products. TÄV SÄöD holds recognition in both Europe and the United States. Thirdly, DEKRA is another reputable German certification body that delivers a wide array of testing and certification services, including C and UL approvals. Fourthly, SGS, a Switzerland-based company, offers comprehensive testing, certification, and inspection services. SGS maintains a global presence and provides assistance with approvals for multiple countries. Fifthly, Bureau Veritas, a French certification body, provides testing and certification services across various industries, including electrical and mechanical equipment. Working with these agencies provides several benefits. These agencies serve as a single point of contact for all approval and listing needs, streamlining the process and reducing the administrative burden. These agencies have established relationships with regulatory authorities worldwide, which helps ensure acceptance of certifications. By coordinating approvals and listings, these agencies help avoid duplication of tests and reduce overall certification costs. They have streamlined processes and efficient testing facilities, which accelerates the approval process and saves valuable time. Several tips can minimize costs and effort during the certification process. Select a certification agency that has the expertise and experience to meet specific requirements for multiple approvals and listings. Start the approval process early to allow sufficient time for testing and certification. Ensure all necessary documentation, including technical drawings, test reports, and design specifications, is provided to avoid delays. Explore the possibility of obtaining approvals and listings for multiple jurisdictions through a single certification process to reduce overall costs. Contact multiple agencies and negotiate discounts based on the scope of the project and the number of approvals required. Class 1 Division 2 is a hazardous location classification defined in the National Electrical Code, NEC, Article 500. It refers to locations where flammable gases, vapors, or liquids may be present in the air under abnormal conditions. Equipment intended for use in Class 1 Division 2 locations must be designed and tested to prevent ignition of these flammable substances. CE marking indicates that a product conforms to health, safety, and environmental protection standards for products sold within the European Economic Area. It signifies that the manufacturer has verified that these products meet all relevant requirements. UL listing means that Underwriters Laboratories has tested representative samples of a product and determined that it meets UL requirements for safety. It signifies that UL has found that the product is free from reasonably foreseeable risk of fire, electric shock, and related hazard. The International Electrotechnical Commission (IC) is a global standards organization that prepares and publishes international standards for all electrical, electronic, and related technologies. The International Organization for Standardization (ISO) is an independent, non-governmental international organization that develops standards to ensure the quality, safety, and efficiency of products, services, and systems. The NEC, published by the National Fire Protection Association (NFPA), provides comprehensive electrical safety requirements for electrical wiring and equipment in the United States. It is updated every 3 years. When selecting a certification agency, verify that they are accredited by a recognized accreditation body. Accreditation ensures that the agency is competent to perform testing and certification services. Check the agency's experience and expertise in the specific industry and product category. Agencies with relevant experience are better equipped to navigate the complexities of the certification process. Inquire about the agency's familiarity with the specific standards and regulations applicable to the product and target markets. This knowledge ensures that the product meets all necessary requirements. Request a detailed proposal from each agency outlining the scope of work, testing procedures, and associated costs. This allows for comparison of services and pricing. Ask for references from other clients who have used the agency's services. Contacting these references provides valuable insights into the agency's performance and reliability. Before starting the certification process, conduct a thorough review of the product's design and documentation. Identify any potential compliance issues early on and address them proactively. Ensure that all product documentation, including technical drawings, specifications, and test reports, is complete and accurate. This information is essential for the certification agency to assess the product's compliance. If possible, conduct pre-compliance testing to identify and address any potential issues before submitting the product for formal testing. This can save time and money in the long run. Stay informed about any changes or updates to applicable standards and regulations. This ensures that the product remains compliant throughout its life cycle. Maintain open communication with the certification agency throughout the process. Promptly respond to any questions or requests for information to avoid delays. Obtain a certificate of compliance or listing mark from the certification agency upon successful completion of the certification process. This certificate demonstrates that the product meets all applicable requirements. The cost of product certification can vary depending on several factors, including the complexity of the product, the number of standards to which it must be certified, and the agency selected. Obtain quotes from multiple agencies to compare pricing. Negotiate discounts based on the scope of the project and the number of approvals required. Consider bundling multiple certifications together to reduce overall costs. Explore government programs or incentives that may provide financial assistance for product certification. Plan the certification process carefully to minimize the need for retesting or rework. Accurate documentation and thorough preparation can save time and money. The time required for product certification can vary depending on the complexity of the product the agency selected and the availability of testing resources. Plan the certification process well in advance of the product launch date to avoid delays. Work closely with the certification agency to expedite the testing and approval process. Ensure that all necessary documentation and information are readily available to the agency. Consider using expedited testing services, if available, to shorten the certification timeline. The penalties for non-compliance with product safety standards can be significant, including fines, product recalls, and legal action. Ensure that all products meet applicable safety standards before being placed on the market. Implement a robust quality control system to prevent non-compliant products from reaching consumers. Stay informed about any changes to product safety regulations and update product designs and manufacturing processes accordingly. Work closely with certification agencies to ensure ongoing compliance with applicable standards. Wire colors in electrical wiring installations are governed by electrical codes and standards, such as the NEC in the United States and the IEC in Europe. These standards specify the colors used for different conductors to ensure safety and proper identification. In North America, the NEC specifies the following color codes for branch circuits: 120/240 volt single phase. Black is used for the hot or live conductor. White is used for the neutral conductor. Green or bare copper is used for the grounding conductor. For three-phase systems, the NEC specifies different color codes for the hot conductors. For a 120/208 volt system, black, red, and blue are used for the hot conductors. White is used for the neutral conductor. Green or bare copper is used for the grounding conductor. For a 277/480 volt system, brown, orange, and yellow are used for the hot conductors. Gray is used for the neutral conductor. Green or bare copper is used for the grounding conductor. In Europe, the IEC specifies the following color codes. Brown is used for the live conductor. Blue is used for the neutral conductor. Green and yellow is used for the protective earth conductor. These color codes are generally consistent across Europe, but there may be some minor variations in certain countries. The choice of wire color can have a significant impact on the safety and effectiveness of electrical wiring installations. Using the correct color codes helps to prevent accidental contact with live conductors, which can lead to electric shock or electrocution. Proper color coding also makes it easier to identify and troubleshoot electrical circuits. In addition to the standard color codes, there are also some common practices for marking wires with colored tape or labels. For example, it is common to use red tape to mark hot conductors and blue tape to mark neutral conductors. These markings can help to further improve the safety and clarity of electrical wiring installations. It is important to follow the applicable electrical codes and standards when selecting and using wire colors. Failure to do so can create a safety hazard and may result in fines or other penalties. Always consult with a qualified electrician if there are any questions about the correct wire colors to use in a particular application. Here are some additional tips for using wire colors safely and effectively. Use the correct color codes for the type of electrical system being installed. Clearly label all wires with the appropriate color codes. Use colored tape or labels to mark wires if necessary. Inspect electrical wiring installations regularly to ensure that the color codes are still visible and accurate. Never assume that a wire is safe to touch, even if it is the correct color. Always use a multimeter or other testing device to verify that a wire is not live before working on it. The standards provide detailed requirements for the design, construction, and testing of electrical equipment for use in hazardous locations. These requirements are intended to minimize the risk of ignition of flammable substances. Equipment certified for Class 1 Division 2 locations must be designed to prevent arcs, sparks, or hot surfaces that could ignite flammable gases, vapors, or liquids. This may involve using explosion-proof enclosures, intrinsically safe circuits, or other protective measures. The certification process for Class 1 Division 2 equipment typically involves testing by a recognized testing laboratory such as UL, CSA, or Intertek. The testing laboratory will evaluate the equipment to ensure that it meets the applicable standards and requirements. Once the equipment has been certified, it will be marked with the certification mark of the testing laboratory. This mark indicates that the equipment has been tested and found to be safe for use in Class 1 Division 2 locations. The selection of a certification agency depends on the specific requirements of the product and the target markets. Consider the agency's expertise, experience, and accreditation. Obtain quotes from multiple agencies to compare pricing and services. Verify that the agency is recognized by the regulatory authorities in the target markets. Choose an agency that can provide comprehensive testing and certification services. Select an agency that can offer efficient and timely service. Consider the agency's reputation and track record. Look for an agency that has a strong commitment to quality and safety. Select an agency that can provide ongoing support and guidance. The wire colors specified by the NEC and IEC are intended to provide a clear and consistent way to identify electrical conductors. This helps to prevent accidental contact with live conductors, which can lead to electric shock or electrocution. Proper color coding also makes it easier to troubleshoot electrical circuits. The NEC and IEC wire color codes are based on years of experience and research. These codes have been proven to be effective in reducing the risk of electrical accidents. Following the NEC and IEC wire color codes is essential for ensuring the safety of electrical wiring installations. Electrical safety is a critical concern in any electrical installation, whether it is a residential, commercial, or industrial setting. Adhering to established standards and best practices helps minimize the risk of electrical hazards and ensures the safety of people and property. Certification agencies play a vital role in verifying that electrical products and systems meet the required safety standards. These agencies conduct rigorous testing and evaluation to ensure that products are safe to use and comply with applicable regulations. Compliance with electrical codes, such as the NEC, is essential for electrical safety. These codes provide detailed requirements for electrical wiring, equipment, and installations. Regular inspections and maintenance of electrical systems are crucial for identifying and addressing potential hazards. This includes checking for damaged wiring, loose connections, and overloaded circuits. Proper grounding of electrical systems is essential for preventing electrical shock. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. Ground fault circuit interrupters, GFCIs, are life-saving devices that protect against electrical shock. GFCIs monitor the current flowing in a circuit and trip the circuit breaker if they detect a ground fault. Arc fault circuit interrupters, AFCIs, are designed to protect against fires caused by electrical arcs. AFCIs detect the unique characteristics of electrical arcs and trip the circuit breaker to prevent a fire. Surge protection devices, SPDs, protect electronic equipment from voltage surges caused by lightning or other electrical disturbances. SPD divert excess voltage away from sensitive equipment, preventing damage. Proper lockout/tagout procedures are essential for safely working on electrical equipment. Lockout/tagout procedures ensure that electrical circuits are de-energized and cannot be accidentally re-energized while work is being performed. Electrical safety training is essential for all workers who work on or near electrical equipment. Training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment. Personal protective equipment, PPE, such as gloves, safety glasses, and insulated tools should be used when working on electrical equipment. PPE provides an additional layer of protection against electrical hazards. Maintaining a safe work environment is essential for preventing electrical accidents. This includes keeping work areas clean and uncluttered, providing adequate lighting, and ensuring that all electrical equipment is properly maintained. The NEC is a comprehensive set of standards that covers a wide range of electrical safety topics. Some of the key areas covered by the NEC include wiring methods, overcurrent protection, grounding, and equipment installation. Article 210.8 covers GFCI protection for personnel. It mandates GFCI protection for receptacles and dwelling units, including bathrooms, kitchens, and outdoor areas. Article 230 covers service entrances. It provides requirements for the installation of service conductors, service equipment, and grounding electrodes. Article 250 covers grounding and bonding. It provides requirements for grounding electrical systems and equipment to minimize the risk of electrical shock. Article 300 covers wiring methods. It provides requirements for the installation of electrical wiring, including conductors, cables, and raceways. Article 400 covers flexible cords and cables. It provides requirements for the use of flexible cords and cables, including their construction, installation, and use. Article 430 covers motors, motor circuits, and controllers. It provides requirements for the installation and protection of motors, motor circuits, and motor controllers. Article 440 covers air conditioning and refrigeration equipment. It provides requirements for the installation and protection of air conditioning and refrigeration equipment. Article 500 covers hazardous locations. It provides requirements for electrical equipment and wiring in hazardous locations where flammable gases, vapors, or dust may be present. The NEC is updated every 3 years. It is important to stay up to date on the latest changes to the NEC to ensure compliance with electrical safety standards. Regular inspections and maintenance of electrical systems are essential for identifying and addressing potential hazards. A qualified electrician should perform these inspections. During an electrical inspection, the electrician will check for damaged wiring, loose connections, and overloaded circuits. The electrician will also test GFCIs and AFCIs to ensure that they are functioning properly. The electrician will provide a report outlining any safety issues that need to be addressed. Addressing electrical safety issues promptly is essential for preventing electrical accidents. The National Electrical Manufacturers Association (NEMA) is a trade association that represents electrical equipment manufacturers in the United States. NEMA develops standards for electrical equipment and provides information on electrical safety. The Institute of Electrical and Electronics Engineers (IEE) is a professional organization for electrical engineers. IEE develops standards for electrical engineering and provides educational resources on electrical safety. The NFPA is a non-profit organization that develops codes and standards for fire safety. The NFPA publishes the NEC. The Occupational Safety and Health Administration (OSHA) is a federal agency that sets and enforces workplace safety standards. OSHA has regulations covering electrical safety. The Consumer Product Safety Commission (CPSC) is a federal agency that protects the public from unreasonable risks of injury or death associated with consumer products. The CPSC has regulations covering the safety of electrical products.